So I'm going to talk about GANs, which are a kind of a neural network, and they are super interesting. Let me turn on my little clicker here. Come on, buddy. All right, let's try that again. Okay, so before going into what a GAN is, I mean, build up some basics here. So GANs are based off of neural networks, so they're a certain type of neural network. So what is a neural network? Most people have heard of what a neural network is, but they are very intimidating. If you go and Google what a neural network is, you'll see something like this. And quite honestly, unless you're actually building something that's using a neural network, you don't care about this level of detail. This is way too complicated. So I'm going to simplify it greatly for you guys. This is a neural network. A neural network is a black box. It takes something as input and it returns some output. And that's all it is. That's all you should really care about in terms of a neural network. You're probably more familiar with this kind of neural network where it's going to do some kind of recognition, like facial recognition. So here's a neural network that has 3 outputs, where if you give it a photo, it'll tell you if it's Mark, Jerry, or Kathy. Now this neural network doesn't actually output the actual words Mark, Jerry, or Kathy. What the actual output is a percentage, and this is a confidence of how confident it is that whatever input it was given was that certain answer. So this is an untrained neural network where it said, given this picture of Kathy, it only was 34% confident that was Kathy. And what happens kind of behind the scenes is it'll look at that amount of error and try and back propagate that and turn the knobs inside that black box to do better next time. So if you have another photo, it'll say, okay, now that I've adjusted things, let's take another guess. And this time it does a little bit better of detecting Jerry. So it'll kind of adjust based on the error that happened in there. Then you have a picture of Mark, and again, based on how it's adjusting things, it's over time it's going to be getting better and better. So that is a neural network in a nutshell. Now, there's a sort of interesting question I think you could ask, which is, can you run this backwards? Can you say, hey, neural network, give me a picture of Mark. Tell me what you think Mark looks like, and will it output what it thinks Mark looks like? Mark, I'm glad you showed up to this because this is fun. The short answer is no, that's not how the math works behind the scenes, but you can do something like that using something called a GAN, which is so the acronym GAN is Generative Adversarial Neural Network. Generative meaning in the sense that it's going to generate some data for you that is representative of your training data. And the adversarial part is what you're actually doing is you're taking 2 neural networks and you're having them compete against each other. So again, you have a discriminator neural network and a generator neural network. And at a high level, this is how training these 2 networks works. You first start off by giving the discriminator just a real photo, and it has a single output. And that output is basically going to be, is this photo real? Was it part of the real training set, or is it fake? Did something else make this up? And if it's real, it's going to be close to 1. If it's fake, it's close to 0. And it's going to take some guess. It's going to be kind of bad at guessing at the beginning because it's not trained yet. And it's going to look at how far off it was, and again, back propagate that error behind the scenes in this little box, and try and do it better next time it sees a photo like this. Then you have the generator. And what the generator does is it takes a completely random number as input, and as output, it produces a photo, which is kind of cool. So at the very beginning, this won't be like a convincing photo, but it'll be a 2-dimensional array of pixels. And then what you do as part of the training here is you give that photo to the discriminator. The discriminator is going to guess again at whether it's real or fake. And based on how far off it was, the discriminator will kind of update its internals to do better next time. But the generator is also going to look at the output and update things in the opposite direction. The goal of the generator is to make the discriminator as wrong as possible. And in doing so, they get into this sort of race, arms race, where one's trying to do better at detecting faces, the other one's trying to do better at tricking it. So if you run this, for a very, very long time, what you'll end up is with a generator that if you give it literally any random number, it'll produce something that's convincing. So let's look through an actual run of this. I don't actually have enough photos of Mark, Jerry, and Kathy to be able to do this, so I won't be able to do this, generate a picture of Mark, but there are free and open source data sets where you have like pictures of celebrities, where there's just hundreds of thousands of photos. So we're going to create a celebrity face generator, which is kind of fun. So the way this works is you give it a picture of a celebrity, The discriminator will take some kind of guess, and again, train itself on how wrong it was and try and do better next time. Then we look at the generator, and you give it some random number, and at the very beginning, the generator is terrible, and it's basically white noise in, white noise out, and that's why that photo looks absolutely terrible. But the photo is given to the discriminator. The discriminator takes some kind of guess, and again, the discriminator is going to try to minimize the error that it had, and the generator is going to try and maximize the error that the discriminator is doing with that guess. A couple hundred generations pass, and again, we're feeding it more photos of celebrities. The discriminator is getting a little bit smarter. Generator's turn, give it a random number. Again, it's white noise in, white noise out. I don't know how well you can see it on this TV, but you're starting to see the beginnings of a face. Like there's some dark areas for eye, maybe some hair, and so on. So it's actually, starting to produce something like a face. One iteration here, same sort of thing. Give it real stuff, real faces. Generator will take a guess, and the discriminator would take a guess. But now, as we continue going on, hundreds of generations are passing, the generator is getting better at generating faces. And like, this is really cool. And so we're gonna look at a sort of a longer run here. I didn't run it for like too long in terms of a neural network, but it was for 3 hours on my laptop. And I'll just play it right here. This is a whole bunch of different random inputs going into a generator. And over 3 hours, this is the progression that we're seeing. And the generator is trying different strategies to try and trick the discriminator. And so the discriminator has to get better. And so the generator tries different strategies to produce better and better and more convincing faces, from which the discriminator then has to improve. So they get into this arms race, and it's really fascinating. So just to zoom out for a minute here, what's happening really at bottom is we are producing a generator, which is really a neural network, which is actually just a really complicated mathematical equation. And if you give this mathematical equation any random number, it'll produce a face. That's cool. Like, yeah, so I think that's fun. So after 3 hours of training, it's done animating. I mean, you as a human can tell this is, they're very clearly faces, but yeah. Yes, I agree with ours. It's nightmare fuel. Okay. But if you ran this longer, like with the PyTorch library, I'd be tempted to guess that if I didn't put the labels above the images, it wouldn't be immediately obvious which ones were real and which ones were fake. So you can see on the right there, you have the fake images. And some of them, like in particular, like this one, this is a real person to me. Like I can't tell that was generated by a neural network. So that just kind of blows my mind. I think that's kind of cool. So take it in, because I don't know, I get excited about that, and that's fun. All right, so when are we going to be generating faces at work? Never. But how else might we use this? Because here's what the GAN is. You have a random number going in, it produces a photo, and that photo is being trained by the discriminator. Notice here that these two pieces, the photo, in theory, could be swapped out for anything else. So any other problems where you are trying to produce data, this could be useful for. So for example, if we have a project where we're dealing with healthcare records and we wanted to automate some kind of testing and generate and use like thousands of healthcare records to do some sort of integration testing, we wouldn't want to check in those health records into a versioning system, right? Because HIPAA. But what we could do is train a generator that produces random health records that are actually convincing, that are not trivial, that are like, oh, there's an edge case we didn't discover. Maybe we should try and handle that. So that's one potential use case. Again, any kinds of use cases where you're trying to generate data. Another one is maybe you want to do some kind of war games scenario where you are feeding in combat strategies or tactics from historical information, and you want to simulate that for future simulations. That's another idea. So I'm kind of reaching on some of this, but it'd be really cool to use this sort of thing in actual practice. So that's what GANs were. I guess I'll pause here and see if anyone has any questions. Schulte. So the data set was in the hundreds of thousands, I think. So it was very large. Yeah. No, did not use that for the Ninja Robots project. Yes.
Famous.
Most famous example of a GAN. It's still, so all the cutting edge things are around faces. Let me show you this video. And this is insane. So let's see if this is going to work. So this is taking the random numbers that you pass into a GAN and kind of traversing the different solution spaces. And I mean, none of these are real people, but like it's crazy real. And yeah, yeah. This is the best example that I know of a GAN in practice. Yeah. Yes, that is correct. Yes, it is a multi-dimensional vector, and you can actually do, so I'm over time already, but you could actually do examples where you have a vector that represents a man with sunglasses and a vector that represents a man and a vector that represents a woman, and you could add and subtract these vectors and produce a vector that should be a woman wearing sunglasses, and that's the actual output. So you could actually do vector math on that, but well, that was traversing multiple dimensions to try and this video. Yeah. What about it? What's your question? I think it was vector based. So this is me following a tutorial, and so it's mostly out of the box because I just wanted to like show this off. So, all right, I am over time, so I'll wrap things up. So thanks for listening.